We looked at finding the zeros of the quadratic if it was in factored form, and then changing it to standard form. So if we take a look at this quadratic, it has two factors. It means it has two zeros. To find the zeros, we want to know what makes each factor equal 0. Oops. Okay, so the first factor, this one's pretty easy. X would be -1, would make this factor equal 1. But the other one, if it's not as apparent, we can make an equation. 3x minus 2, what makes that equal 0? We can solve our equation. Let's add 2 to each side. We get 3x equals 2, divide by 3, so x equals 2/3 will also be a 0 of the graph. So it would cross at -1 and 2/3, so it looks something like this. We can write this quadratic in standard form, which means no parentheses, if we multiply it out. So again, it was 3x minus 2 times x plus 1 and get the inside. This would multiply to 3x squared. We'd have a negative 2x. We'd have a 3x, and we'd have a negative 2. So then when we write it out, we write the highest power first, 3x squared, combine like terms, 3x minus 2x is x, and then we have our minus 2. So here's the equation in standard form, no parentheses. So today we look at the final form. It's called vertex form, and it does what it sounds like. It helps you find the vertex without doing that opposite b over 2a. So we'll do an investigation in class. We're going to start with the parent function, y equals x squared. Let's graph this, and we've graphed this before. But to graph it, we just plug in, I made a table, y equals x squared. So if x is -2, we would plug it in. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So if we were to graph this, here's what it would look like. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. So here's our parent function. What's the vertex of this parent function? Where does it change direction? At the origin or at 0, 0. So here's where it changes direction. The vertex. And that's what we're going to focus on today in class. Restart this. Okay. Investigation, finding the vertex. Open a graph page and graph x squared. Okay, so let's do that. Let's graph x squared. So there's that parabola we just graphed by hand. Type in this equation, x minus 2, x minus 3 squared plus 1, and see what happens. All right, so hit tab, parentheses, x minus 3 squared plus 1. The new vertex, it looks like it went over 3, up 1. So this new vertex is 3. Let's try another one. Go back up to f2 of x, erase the previous function, and type in this one. X minus 2 squared minus 3. So tab, go up. And this should be minus 3. All right, this new vertex is 2 over and down 3. Let's try it again and look for a pattern. So erase, type in x minus 1 squared plus 4. And you can make a prediction on where this is where the vertex is gonna end up. Plus 4. Oops. And this new vertex is 1, 4. All right, so let's start looking for a pattern here. If this is the equation, minus 3, 1, this ends up being 3, 1. If this is minus 2, minus 3, this ends up being 2, 3. This is minus 1, 4, this ends up being 1, 4. So make predictions or use your calculator and see if you can predict the vertex of the following functions. All right, and then make a prediction. Okay, so here's the rule. If we look at it, the x plus 3 will move the graph left 3, up 2. So this will be negative 3, 2. If you notice, it's the opposite of what's inside the parentheses, but what stays on the outside of the parentheses stays the same. So it says enter an equation that will have a vertex at 4, 1. So if we type that in, it's going to be the opposite of the x value, squared on the outside, plus 1. How about this one? Negative 3, negative 1. It's going to be the opposite of the negative 3, and then that minus 1 will stay the same. So the rule is opposite of the thing inside the parentheses, but the thing outside stays the same. So make a prediction. The opposite of negative 3 is 3, and the minus 1 stays the same. The opposite of negative 2 is 2. There's nothing on the outside, so that's 0. Here there's nothing in the parentheses, so that's 0, and it's minus 2 down 2. The opposite of 5 is negative 5, and then we have negative 4. We can try graphing these and see if these numbers affect the graph, and they affect the direction of the graph. So here the vertex would be negative 2, 4, and here the vertex would be negative 3, 1. But the direction of this, the minus will make it go downward, and the positive 2 will make it go upward. Okay, so summary, if you have something in the parentheses, the vertex will be the opposite. If it's on the outside, the number will stay the same. So how do you know if a vertex is an absolute max or min? It depends on that a value, this number in front. Negative a will be a min, a max, because it looks like this. A positive a will be a min, because your graph will look like this. Okay, last thing for today, can you multiply this out? Change to standard form. Follow order of operations. So first is exponent before you multiply or add. So first step, we're going to do x plus 2. I'm not going to use parentheses here. Okay, so here's the first part. X plus 2, x plus 2. We'll get x squared, 2x, 2x, and 4. So we'll get x squared plus 4x plus 4. There's the first step. The next step is multiply everything by negative 3. So here's step 2. Distribute. We'll get negative 3x squared minus 12x minus 12. Okay, so again, step 1, use a box, multiply it out. Step 2, distribute the negative 3. Step 3, we have this plus 4 at the end. So combine like terms and rewrite. Negative 3x squared minus 12x minus 8 is our equation. All right, let's try this one more time. Again, just order of operations. Convert to standard form. First step is just multiply out x plus 5 squared. X plus 5, x plus 5. We'll get x squared, 5x, 5x, and negative 25. So let's write that out. X squared plus 10x minus 25. The second step is to multiply everything by this number outside the 2 here in this case. So we'll distribute. We'll get 2x squared plus 20x minus 50. The last step, step 3, is you have this plus 1 hanging out at the end. So combine like terms, and we'll get 2x squared plus 20x minus 49. So this is changing from vertex form to standard form. The vertex of this guy would be negative 5, positive 1. The vertex of the other one would be negative 2, positive 4.